Check one, check two. I guess it's just me, myself, and I again. Hello, welcome. This is the Module 8 live session presentation and lecture for the IBM Data Analytics Professional Certificate. My name is Alexander Booth. I'm the head program instructor and head facilitator for the Data Analytics Bootcamp Professional Certificate thing through IBM. And like I said, this is our week 8 live session. Should be a pretty good week today. I'm excited for it. It's data visualization week. So we'll be talking about static, interactive, and dynamic data into data visualizations, as well as data applications, business intelligence, dashboards, and kind of where the consumption layer fits in terms of the overall data ecosystem and architecture. So yeah, let's get moving along here. I think I have the some slides, but there's really nothing in them, especially for just a couple of y'all that watch this. So yeah, let's just jump straight into kind of the materials. I obviously already have my lecture notes ready to go, as well as GitHub and everything. So maybe we'll start there. And friendly reminder, after this, we still have a couple more live sessions to get us through the end of the capstone. I know some of you are already working on week 9 already, so that's awesome. But we are still a little bit behind in terms of the live sessions just because of how the course materials were released and scheduled. That was a small bug in that, where I think weeks 1 and weeks 2, or week 1 and the orientation week or something was all released at the same time. So even though week 9 is open, we are still wrapping up week 8. Let's see. Like I said, week 8 is a good week. We're going to be focusing on data visualization, from static visualizations, EDA, to interactive geographic visualizations, dashboard design concepts, and data applications. Data visualization matters because it helps us communicate and understand our data, as well as pass it on downstream to non-technical stakeholders for decision making and actionable insights. We kind of talked this a little bit in our last class. There are three main use cases for data visualization. The first is for static reporting. So this is like making a graph or a chart for a slide deck or for a white paper or for some kind of one-off static report, or maybe something that gets like emailed out or something every single day. The next is data visualization for exploration. So this is more on the data scientist, the data analyst, to explore the data, look for the data distributions, the shape of data, look for skew and outliers, really understand what's there, what could potentially be real signal, and then pass that downstream to predictive modeling. We did a lot of that last week in our exploratory data analysis week, where we ended up building those regression models predicting the housing prices in Seattle, right? We really brought up our own domain expertise by looking and visualizing the data in that way. And then finally, moving from static to interactive visualizations, how do we build web-based dashboards and data apps? This is where we kind of conflate business intelligence as well as data-driven applications. Basically, how do we provide self-serve analytics so that our users can filter, drill down, explore, and connect, and again, self-serve themselves answers to their own questions, as opposed to having to go to you, the analyst, or having to write their own SQL queries and commands. So again, how do we go from data in a table to actually clear, honest, and actionable visualizations? We'll be talking a lot about different visualization types today too, whether it's line charts, bar charts, scatter plots, histograms, maps, right? Every data visualization type has appropriate use cases as well as pitfalls. We will spend some time today talking about bad visualizations as well as lying with data viz, and basically with great power and great responsibility with great power comes great responsibility, right? Uh, Data analytics at its core is going to be about truth telling and storytelling. So how do we make sure we actually are telling truthful stories with our data, even if we could skew some of the results? Pretty heavy week in terms of notebooks, but we'll hit a couple of them and then we'll spend the most time kind of on the capstone activity here, the keynote activity for the week, which is will be visualizing wildfires in Australia. So it should be a pretty good week. If I have time, I'll show some one of my favorite notebooks, which is making like advanced data visualizations. So your waffle charts, your word clouds. We actually pull Alice in Wonderland, map all of its words to a word clouds, like which words appear the most, and then format that into the shape of Alice, which is pretty cool. So we'll see if I can show that later. And then, like I said, we'll do Plotly, Dash. And even though we're going to be using Plotly Dash, that's like the name of the text of the software. It's like an open source data application tool. And a lot of these ideas about dashboarding translate into whatever BI tool that you use, Tableau, Power BI, Looker, Click, what have you. It should all be kind of similar concepts at the end of the day. And so our goal here is to use charts to understand data, reveal patterns, and communicate insights. You need to choose the correct plot type and labels and other parts of the visualization, like scales and label and legends, to avoid misleading the audience. We'll talk about the three different like plotting libraries with Matplotlib, it's Seaborn, Folium, Plotly, all that good stuff. You should understand the specific chart types and when to use each, and then building out interactive dashboard design concept. Our goal for this module is to build out your entire visualization toolkit, not just learn or copy syntax or how to make one specific chart. Again, the goal is not to memorize everything, as is tradition, right? There's so much to learn in 10 weeks in this boot camp. You need to learn the 10,000-foot views, the high-level ideas. How do we know the right plots for the question? How do we build clear and honest visualizations, as well as deliver interactive dashboards for non-technical stakeholders to provide self-serve analytics, right? And this is also something that I call the consumption layer. It's how your data is actually consumed by the people utilizing it. So this is also, you may hear like data products thrown around. A dashboard, a machine learning model, an AI agent. These are all ideas of data products that are consumed by stakeholders downstream in some kind of consumption layer or non-technical way. All right, we'll kind of just go through the media sets. And like I said, I think there's a few notebooks that I want to hit, but we'll just tackle them as we go. Let's see, I think our discussion forum is already available and seated, but I guess we'll jump into that when we get there. So let's just start with our first one, data visualization tools. Again, it's pretty straightforward. Um, you'll learn a lot about what is data visualization, how it's used, what it looks like in the real world, and then specifically in Python, what are going to be our plots that we will use, as well as the different types of plots here. So Matplotlib is essentially like the root canvas for making data visualizations in Python. Everything else, like Seaborn, Waffle, a lot of that stuff is like built on top of Matplotlib, right? So Matplotlib is the framework. It also is integrated into Pandas, so we can quickly create data visualizations from our dashboards as we go. And yeah, I love Seaborn. We talked a lot about Seaborn in the EDA week. But if you have time to look at it, or maybe even do one of the Kaggle learns on Seaborn, which one is? Oh, the data visualization one. I love it. It's one of my favorite Kaggle learns out there. And yeah, like I said, Seaborn has some of my favorite visualizations ever, going from violin plots to your facet grids to your histograms and pair plots. So yeah, we'll see some of this stuff going into the capstone, as well as later on in the lecture. All right, Matplotlib basics. Basically, how do we define our canvas? How do we start plotting information onto it in different ways? And we have a real world example here where we start cleaning and preparing data for immigration into Canada and then looking at patterns over it. Note that we have a little cheat sheet here for just like pre-processing in Pandas, and this is also available in my GitHub already as well with this Pandas cheat sheet. Just like with anything else to go into the consumption layer, it all depends on the underlying data. What do I always say, right? Garbage in, garbage out. If you have bad data layout, bad or misleading information or missing information in your columns and rows, then visualizing that data is not going to be very easy, right? So we need to use pandas to manipulate, clean, and wrangle our data to prepare it for data viz, just as if we were going to prepare it for predictive modeling, regression analysis, all that good stuff as well. There's actually one of the questions on the quiz. I'm pretty sure it's John Hunter who created Matplotlib. We'll review the week 8 quiz at the end. Oh, correct. Well done. Thank you. I appreciate that little word of affirmation there. Let me make sure I know which ones I want to review here. Let's see. Introduction to Matplotlib and line charts. I think that is this one. Actually, no, that's data wrangling. All right, so let's keep moving. We're gonna dive into Matplotlib here. So I'm in 8.3. This will be our first notebook that we're going to review. Essentially, it's going to be a soft introduction into creating visualizations with Matplotlib. 8.2, again, is just a data wrangling notebook. So it makes you practice and review your skills with working with pandas, cleaning and preparing data, and a lot of things that we did in week 7 with our exploratory data analysis week, as well as in week, what, 5, 4, 6, 5, whatever it was before the sequel week. I think we did what, sequel in week 6, right? So we did pandas in week 5, I think. Let me just double check that. And I'm just wasting time while I think, what are all these? Yeah, we did sequel in week 6. So we must have done some more Python stuff in week 5. Yeah, okay, yeah. So we did some Python stuff in week 5. All right, and I still promise that I'll send out the module 4 lecture when I get to it, which should be any day now. I actually like did all my notes and stuff over the weekend. I was supposed to record it over the weekend, but things kind of got away from me. So I'll send that out when I do it. And then, like I said, I think the old instructor did modules 1 and 2 and probably 3. And then, like I said, you're with me until the end. Don't forget that on YouTube already as well, we have I have a whole playlist for our cohort, and you'll see here that I have our some weekly recaps that I do as well. So at the end of week 6, at the end of week 7, at the end of week 8, I'll have a week 8 recap and a week 9 preview that'll come out on Friday or Saturday. All right, let's get after things. Here's our notebook. Let's go ahead and clear all outputs, and then we'll start running it. All right, so this first cell will take a hot minute to run, just because oh, our kernel died, so we got to refresh our page. Classic IBM Cloud, Watson notebooks. All right, we're in. Our kernel's online. That's why we have that clear circle. So let's again just try and clear all outputs. Success. And let's try not to crash our compute. All right, there we go. So this is all just going to be doing some installs. We only have to do this once. I think we use the same compute for all of our notebooks this week. So this won't take too long. We're going to go fetch our data. We're going to be, again, fetching that same immigration data set. Again, this is going to hopefully be already fairly clean because I'm pretty sure we cleaned it in the last notebook. But there we go. We can look at our data. And again, the way that our data is set out, we have the incoming country and their continent and region, and then some other categories about it. We have the year, and this year is then going to have the number of immigrants from that country into Canada. So the way to read this, in 2013, we had 4,331 immigrants from Algeria for a net total from 1980 to now of 69,439. All right, so we're going to just make our data frame look a little bit nicer. We're going to pull all the years that we're going to be using. You'll maybe see where this is going, where we can use this in our x-axis, and we'll go ahead and start doing our introduction into Matplotlib. Like I said, Matplotlib is the basis for a lot of visualization libraries in Python. It's going to have a canvas, which we then draw axes and draw our shapes on. I know we're going to use a default style. Default styles are nice because they make your graphs look good without really having to do much work. ggplot is good. 538 is good. Yeah, there's a couple of good ones in there. Let's see. I also like the Seaborn ones, obviously. I like the 538 one's pretty fun. RIP to 538. Yeah, anyway, play around with that if you can on your own time. All right, so let's do our first kind of visualization in our time. In our goal here, we're going to visualize the immigration from Haiti. A little bit of context here. We're going to see if we can tell this story about this earthquake in 2010 with the data in terms of visualization. Now, one other thing to note is that because we're trying to visualize change over time, our axis is a time series, right? We're looking at immigration over years. We're going to be looking at line plots to be able to tell this story. Like I mentioned as well, Matplotlib is automatically built into Pandas. So in this one case, all we're doing is adding this dot plot command. And by default, you'll see, so I can pull it up, Pandas plot. There we go. You'll see that by default, it's going to be a line plot by default, which is pretty nice. But we have all these things that we can do to customize our visualization, adding in our X and Y data sets, adding in our labels, grids, legends, all that good stuff. So let's look at this, and wow, we have a really easy line chart. Pretty cool. And again, we see a huge spike happening right after 2010, and that's going to be from the earthquake. All right, so let's clean this up. I like being more specific with my plots. So we're going to use Pandas plot as a line chart. Then we're going to use Matplotlib to add in our titles and labels, and then we'll show the graph. So there we go. Notice my labels here, and it also rendered really quickly. We're going to add an annotation to highlight the 2010 earthquake. And now with just the few lines of code, we're able to make and tell a pretty compelling story here in terms of immigration and other um, global like catastrophes that can cause that spike in terms of refugees. All right, so let's also do this for a few other examples. Let's compare the number of immigrants from India and China to Canada. So here is our data table. Really hard to read as humans. It's easier for us to identify patterns in visualizations. So let's plot this as a line chart. And oh no, it didn't work. We end up with one line per year, which is not what we want. We want one line per row with the years acting as a series. So we're going to transpose the data and then re-visualize the graph. And there we go. And I think it's a really interesting graph. The fact that India and China basically mirror each other in terms of total immigration to Canada over this 30-year period. So pretty cool. Again, we see a decent spike in both in 2005 as well. So maybe that could be due to, we could do some research and see if we can understand why that was the case. But we can at least tell the truthful story of the rising immigration from both of these countries to Canada over this 30-year period. All right, let's keep going here. Let's see. We're going to just grab the top five countries. We're going to sort by total, grab our top five countries, transpose them like we did before, and then we're going to make our 5 lines, which is all that this is going to be doing here. And again, you don't have to automate your code all like this. Again, I like being pretty explicit with my visualizations, so I know exactly what I'm graphing. But here we go. And, we can see we got India, China, the UK, Philippines, and Pakistan as our top 5. And I think the UK has a pretty interesting story here as well. We can see going into the millennium a sharp decline in immigration from the UK to Canada. So yeah, maybe that also corresponds to the sharp increase in the Philippines. So I don't know. Again, we're not trying to say why. We're just trying to tell a story here. We're not trying to justify reasons or anything. I know we have some other visualization options that we could do with pandas. Horizontal bar charts, which again are good for categorical data, area charts, pie charts, scatter plots, density charts, all of that good stuff. All right, and note, even though I'm not running all the notebooks, I have already run all the notebooks for the week. So for example, that data wrangling notebook, you should be able to load it up in my GitHub. Again, this is the Data Analytics Week 8, 8.2 notebook. And you'll see I've done all this work already to read in this immigration data from Excel and then do all that cleanup work again. So if you run into any issues running the notebooks in the IBM labs, remember you can always reference my notebooks as a source of truth, or you can just run my notebooks in Google Colab if you want to as well. All right, so let's keep flying on here. I think the next one that I wanted to show is, yeah, maybe we'll just skip to my advanced visualization one. But let's just keep clicking through the media sets here just so we know what we're doing. The 8.4, we're going to start talking about specific types of data visualizations. I think this is honestly one of the more important sections, 8.4 to 8.8 here. Again, you need to know what data vises exist and what they're good for, as well as their pros and cons. Area plots are pretty good at visualizing changes over time, just like line plots. So you can use area plots for time series. I don't really like care too much for area plots. I think they add in a bunch of extra noise and are also kind of hard to read. Again, this is kind of a classic area plot where it's the whole all the categories kind of stack up to their own thing. But again, it's still pretty hard to compare. And I'm not really sure that like the area actually means anything, but they can be kind of pretty graphs. This is kind of a fun one. Looking at again different countries here and then their aggregated household wealth. I think that's probably a good example of area plots. Usually I kind of stick to line charts though. Histograms, density plots, box plots, violin charts, all of those show the shape of data. So again, our goal here is to see if we're normally distributed, if we have skew or crazy outliers in our data, right? What does the shape of data look like? Are we bimodal? What is the signal? What's the cleanliness of our data? Do we have trust in the cleanliness and the health of our data? Again, those data distributions are typically used for exploratory data analysis, where we are trying to come up with our own domain expertise and confidence in any potential signal for predictive modeling downstream. Or even in visualizations, right? If you try to visualize something and you have like crazy outliers, then your leaderboards and charts are going to look kind of funky, right? Bar charts, we're going to know what a bar chart looks like. Bar charts are good for visualizing categories or categories with counts. Pie charts are sum of whole, right? So what percent of whole are we? Remember, with pie charts, you're always going to have percents involved there. We already covered box plots, which is the data distributions, scatter plots, allowing us to look for relationships and correlations between numeric variables and numeric features. And then you have another video on customizing your Matplotlib graphs with markers, colors, and line styles. I'm not gonna run through all these notebooks, but I am gonna quickly kind of deviate from our script here and just talk a little bit about bad visualizations and kind of lying with data. Because all of these different charts, your pie charts, your bar charts, right, even line charts, they can all be used to kind of show and tell different stories. Even scatter plots too can also be used incorrectly to to tell a story and correlation. So let's actually talk. We'll say non-political in this, but I'm gonna use some political images just to showcase some of the abilities to skew and lie with some of these information. So I'm gonna do. Let's see. There we go. Fox News data is ugly. There's a couple of these. Let's start with pie charts. Pie charts are terrible in my opinion. Why use a pie chart when you could just use a donut plot? And we'll talk about why here in a second. With pie charts, obviously, because we're showing percent of whole, everything needs to add up to 100%. In our case here, we have a 63, a 60, and a 70. This obviously does not align up to 100%. And also, it's really hard to compare these, right? If I could look at the 70% of the red slice, compare that to the 60% of the green slice, honestly, I would say that the green slice is bigger, which is not what we're supposed to be seeing, right? If I have a bigger percentage, I should see a bigger chart, right? Or a bigger slice of the pie. This is also pretty easy to do with box plots or with bar charts. So we'll see if this image loads. It's a little bit fuzzy. Let me look at this one. So here's another bar chart. It's it's a religious one. Percentage of Americans identify as Christian. We'll see in 2009 it's 77%, and in 2019 it's 65%. So that's a drop of 12%. But the way they visualize this has made it pretty dramatic, right? It has over exemplified this change and this difference. And it's because of our axes here on the right. You'll see that our axis started at 58 and goes to 78. So because we've zoomed in on the graph, they've that 12% looks a lot more dramatic than if they'd actually gone from 0 to 100. Right. And this is a very common technique, lying with your axes to make and zoom and imply that the change in data is more dramatic than it actually is. Yeah, you'll see that in this one too. Federal welfare received in the USA. This is another bar chart going from 2009 to 2011. And if I just look at this, I'm like, oh my God, what a crazy graph, right? This blast bar is like 3 times bigger than this one, right? That's huge. This is a tiny bar compared to this really tall one, right? So from 2009 to 2011, you're like, oh my God, did we triple our welfare? And then it's like, no, of course we didn't. We went from 94 to 108, right? And we could do some quick math on that. Let me see if I can dig my calculator out. Let me get rid of my little drawings here. Stand by while I dig out my little TI-84. Let's see here. Oh, come on, little pen out of my life. So we are at we increased by 14 million. So 14 divided by 94 is about 14%. So we increased our federal welfare by about 15%, which is not very much, right? And especially it's not the 300% that this graph is implying, right? And again, it's all because we've zoomed in on the axis over here. If we zoom this out to go from 0 to 108, then you'll see that our bars would have barely changed. There's a lot of examples like this out in the world. You can follow the subreddit for data is ugly. It's a pretty funny one. I'm not gonna open this because I don't want you to see my Reddit. But yeah, it's right there. The R data is ugly for like bad data visualizations. One that I will show you is WTF visuals, which is yeah, www.viz.wtf. What a great URL. And again, you can see some crazy visualizations that make no sense out in the wild. These are like live right now. I thought this was a pretty funny one. This is an American football player. His name's Mike Glennon, and it's supposed to show his like career earnings. And obviously, it looks kind of funky with his crazy long neck. But why this is a bad visualization, again, is going to come down to that percent. The Cardinals, $5 million, but this bar right here is about the same size as these other ones, which are all like well under like 40% of that number, right? So, 5 million should not be the same size as 1.8. And then they did good in the 18 million here, but they didn't like keep that scale correctly. Let's see what else we got on this page. This is like new, right? These are all new data, new visualizations being submitted. I saw this one on Twitter a while ago. Let's see here. Da da da. Yeah, again, area like pie charts, semicircle style, like it's always difficult to read. I think our human brains just are have much, yeah, that's not even a real pie slice. That's like a rectangle thing. Our brain just has trouble parsing like wedges and areas, right? Oh, this is a weird one. The time dilation of COVID cases. Like, what is this even supposed to say? Is this an area chart? Like, I don't even know. I guess so. This is really hard to read. And the legend also makes no sense here. Yeah, more gross line charts. Why is this a bar chart? Yeah, also kind of dramatic again. You have 85,000. This is where they lied on the axis. 85,000 up to 130. So again, that's not the quadruple bar size that this is here. More pie charts that don't add up to 100. Again, if you start creeping on this, you're going to see a lot of pie charts that show up as bad visualization. So yeah, when in doubt, don't use a pie chart. At least use a donut chart. There you go. Here's a donut chart. Again, this also makes no sense. This is hilarious. This makes no sense. They got the colors wrong, right? The red should have been the green and the green should have been the red, but whatever. So if you see any good or ugly data visualizations out in the world, feel free to submit them on Reddit or to this over here too. So, yeah, same idea. You start seeing the pattern. You start seeing these all the time, right? And we have a lie. We have a lie in our graph. This is on CNN. So again, it's all politics, right? 35 to 55. So it's only 20%. But they're implying this rise of 41% to 50. Also, the axis is backwards. Why are we going from 2021 to 2018? Again, so you're just reading it wrong. There's another one like this. I don't know if you've seen this one. It's like the gun death chart in Florida. Bad database. I actually may have posted this in the forums. Yeah, the infamous blood graph. Ooh, sounds dramatic. But it is. It's a weird graph. Like here it is. It's supposed to show that like, hey, like this law reduced the number of gun deaths, but they've like flipped the graph upside down. So we actually have increased the number of gun deaths. So it's supposed to show like, hey, we went from 873 to 721, but it actually goes out like when they rolled this law out, even though the bar goes down, it actually increased. They went from about 500 deaths to 800 deaths. And so they annotated real weird points. They flipped the graph upside down, and everyone was like backwards with it. So this is a pretty, yeah. Like, was they actually attempting to trick viewers? Like, probably not, right? She just made her graph backwards and upside down, right? But you actually see this still some other ones. Like here's one in like Iraq's like deaths and stuff, right? Which is also like upside down and everything, right? There's actually a good graph though, I think, right? Yeah, award-winning data viz. There you go. You can win an award for making a good data viz. Yeah, this is supposed to be a good one because again, you kind of have the motif of the blood and everything, and it actually does make sense. But again, like it's yeah, and they use a donut chart. I love it. I love a good donut chart. Yeah, so anyway, this is pretty. I'll share this graph or this blog. I think it's really interesting. So I think this is supposed to show kind of that other like a better way of doing it, right? Like kind of that raw count. So yeah, gun does have increased. Anyway, it's a pretty interesting blog here. I'll share it in the Slack or in the forums afterwards. All right, let's get back to our regularly scheduled programming. You got a few notebooks here. Again, you can always run them against my GitHub. This will be for area plots, the distribution charts, bar charts. I can show you quickly what that would look like. So you got like 8.5, 8.6, 8.7. You're just practicing making these other types of visualizations. So we got this area chart. Again, I think this is super ugly and is not good at all. And I would prefer the line chart that we built. Let's see. The stacked area chart's a little bit better, but to me, I still think this is really difficult to read, but whatever. Let's see. Histograms, looking at our distribution, we can see we got some right skew in our data, which is important to understand. And then I think that's mostly what we make here. Oh, bar charts. Bar chart for time series. Again, if you have time series, you should probably do a line chart. I think bar charts are better for categories, but that is what it is. I like the annotation though. I think that's pretty fun. And then here's a real bar chart. So this is what I would do, right? Like this is a good use case for a bar chart. I probably would have trimmed the UK label, but other than that, it's pretty good. I like the annotations here as well. And again, this is a good example of a static visualization. Same thing for some of these other ones. I think here we are building a pie chart and a bubble chart. So we can kind of see what all this looks like. Yep, here's our pie chart. Again, super ugly. Here's a little bit better one. Again, still pretty ugly, kind of hard to read. If I didn't have my annotations, would you know that the gray one is bigger than the red one? Like, probably not, right? That's something to be careful about. Different ways of styling this, making your box plots. If you're gonna make box plots, just do it in Seaborn. Matplotlib box plots are super ugly, as you can tell. And then, yeah, now we have the box plots next to our line chart. So this is the concept of axes, multiple visualizations on one canvas. And let's see, scatter plots, regression, bubble charts, all this good stuff. I kind of like the bubble plots. I think these are kind of fun as well. But again, for linear time series, this probably should have just been a line chart. It's kind of hard to like connect the dots here myself, right? But yeah, pretty cool. And then 8.7, which is going to be, I think this is other plotting work. Yeah, we'll be creating all these other ones again. Line chart, scatter, bar, histogram, pie. So we're creating every single graph in just one notebook. So creating our line chart, total immigration over time, styling it, adding in our customizations with our marker choices, grids, and colors. Um, Making, yeah, scatter plots, and these are some really ugly grid lines, but whatever. Bar charts, looking pretty good again. We're grouping by our category and then visualizing it against some numeric value, in this case, total immigration. Histograms, more ugly bar charts. Pie chart, that looks not bad. But again, like if I didn't have the annotations, comparing blue to orange and green to yellow to blue would have all basically been impossible. So yeah, these are all like your basic visualizations. So if you need some review with all of that, definitely go through those notebooks. All right, so I think that takes us to the discussion forum. Yeah, I was like, sometimes I do 8-7 in my live run like lecture, but I just love 8-10. So, okay, there we go. We can see the example of misleading gun deaths. Right, that's what we just talked about. Okay, there we go. Yeah, there you go. The gun deaths in Florida again. So I think maybe I'll share this one instead of the, well, no, I'll probably still share the medium one, but there you go. So yeah, the actual discussion forum here, definitely recommend participating if you can. Uh-oh, my headphones died. It's all right, we'll keep them on, I guess, just for the look. But yeah, you'll see that we have this discussion post about decluttering and cleaning up data, making sure the data is readable, communicating your thoughts effectively. So I kind of seeded this with a couple of my thoughts here, with a couple of graphs and things that I've seen over the last week. So again, for me, how do we make sure that the chart is readable and is not necessarily distracting from the story? Like I said, things that I hate, lots of random colors, overcrowded labels, unnecessary grids, misleading scales, right? Anything that's hard to interpret is usually a bad thing, right? So when decluttering a chart, what is the message we're trying to tell? What information is essential here? And is everything guiding the viewer towards the right conclusions? There's a lot of chatter in this space around, you'll hear like Edward Tufte, Tufte's principles for data visualization. You see he's got like kind of a lot here, right? Elimination of chart junk. That's basically a lot of that, right? Like if you have crap basically that's distracting or excessive, that's only there to jazz up the graphic, then you probably can just get rid of it. And you want to maximize the amount of ink that is serving and telling your data story as opposed to ink that is adding in like redundancy and irrelevant things. A lot of good discussion around graphical integrity as well. I'll share this Medium post. I reviewed this as well. I think it's a pretty good one. Good representation, like how do we just make sure that we're not lying and that things are easy to understand, right? Clear labeling, removing that extra ink in the background, all that good stuff, right? So just making easy, readable, clear graphics, right? Removing random, like I hate 3D charts. Like, I don't think there's ever a good reason to do a 3D chart. But how do we make sure that our data story is not distorting from the truth and the underlying data there underneath? So all this matters when decluttering and cleaning up your data visualizations. I linked WTF already over here, as well as kind of showed what I mean about kind of the lying in the scale of the y-axis. So again, here we have Joe versus Fred. It looks pretty neck and neck. We know that the people often favor winners. So if I'm going to show this on TV, and instead of showing that it's a pretty tight race, of like 51% to 49%, we can adjust our axis. Same data, different representation. Now it looks like Fred is beating Joe in a landslide. So now people are more likely to vote for Fred. So keep that in mind. This is an elections year, midterms in the United States. Let's see. And you'll see this like all the time. Like 44 is not really that different than 36. So this is actually like a real like Facebook post, basically. Like there's no scaling at all here, and everything, nothing like lines up, and it's not proportional at all. So kind of crazy. All right, let's move into some advanced visuals. I'll probably fly through a couple of these. I probably don't necessarily have time to do my waffle chart, but we're gonna do it anyway. I think to hit, I think we got about 20 minutes to hit the hour, so I think we're good on time actually. Note everything in Unit 2 you don't really need to know about. Even Folium, I think Folium is pretty cool. I think we'll do a little bit of it in the capstone coming up in weeks 9 and 10. But note that like really the core this week is Unit 1 and then Unit 3 with our dashboard design concepts and data apps that we build. But anyway, I think waffle plots, regression charts, maps, I think all of these are really, really interesting. But note that it's more like supplemental. But I am going to run the notebook just because, like I said, it's one of my favorite notebooks in the entire course. Note that you also don't have to download screenshots of anything. But feel free to save the notebook, save the visualizations if you want, as they always look good in your public portfolio. The same idea. Let's go ahead and clear our inputs and start running here. All right, so for the waffle charts, again, we're going to be dealing with that same Canada immigration data set. Waffle charts, they kind of show, like, again, the proportion of whole, but in a little bit better ways than pie charts. Basically, you get little square, it's almost like a grid. You get little squares, and you shade in the squares that are yours. If I have 100 squares, or a grid, like a 10 by 10 grid of 100 squares, if I shade in 30 of them, you already know that's like 30%. And again, since these are kind of blocky, it's easier for our human brains to see the patterns and the differences in the visualization. It's an interesting visualization. Yeah, it can also show progress towards a goal. Like I said, that's also something that I think is good for proportional or percentage based data viz. So again, like progress towards a goal, same idea, right? 0 out of 100. I'm 40% of the way to my goal, so we're going to shade in 40% of the squares. Let's see. So we're gonna make a really ugly one first. So this, they're trying to make one just with native Matplotlib, which is interesting. Again, this is not how I would ever make a waffle chart, but here we go. Using general Matplotlib, we're able to kind of build out this really ugly waffle chart. And again, notice how like our shading here, blue is gonna, oh, let's prettify it and then we'll go over it. That's a little bit better. So we see all of my different squares. Let's add in our legend. And there we go. We can see that Denmark is blue, Sweden is red, Norway is orange, is gray. And again, we've shaded in all the squares proportionally, and we can see that Sweden is definitely more than Denmark and Norway. So pretty cool. Easier way to show again the percent of whole versus than a pie chart. Let's see. They created a function for this, which I think is also kind of excessive. But whatever. All right, so here's how I would do it in the real world. There's a Python library called PyWaffle to basically do this for you. And again, it's also built on Matplotlib. So again, we're gonna have 50 squares here. No, 20 rows by 30 columns. 600. 2 times 3 is 6. 600. That's 600 squares. So again, a little bit excessive. Um, a little bit hard to read. Again, looking at this, we can see that Sweden is bigger than Denmark, right? So same idea. I may do some, I usually do like 10 by 10. And so we have 100 squares here. So with 100 squares, we can definitely like even count them now. And you can see they got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. 19% of our data is Norway. Cool. All right. Word clouds. Word clouds are awesome. I love me a good word cloud. I used to have like a spike in natural language processing. It was like before Gen AI and all that stuff. I still do. I still care a lot about it. I use a lot of natural language parsing and analytics in my work, in my job, and kind of even with my like sports accounts that I work with now as well. Like articles, scouting reports, things like that. So one good visualization for natural language is a word cloud. Essentially, we want to filter out all the words that don't mean anything. We call those stop words, and then count the word the frequency of all the other words and see what it looks like. So here we go. That's what we've done here. We filtered, I think we filtered out some stop words already, and we end up with this word cloud. Alice is the most common word, said, and then little. So pretty cool. I think that makes sense. Yeah, Alice said, a little queen are some of the most popular words here. But note that we can clean this up a little bit. Said should be a stop word. So we're going to add said to our stop words and then recreate it. And we end up with this right here, which makes a lot more sense. We see Alice, little, no, one, queen, head, king. These are the real words that we see more often. I think that makes sense. Just looking at these, you get a pretty good picture of how Alice in Wonderland goes. There's a king, there's a queen, there's Alice, little, went, time, turtle, all that good stuff. Hatter, Mad Hatter, the Duchess, all that good stuff. Excellent. This looks really interesting. So now what we're going to do is we're going to try and mask this onto an image. I was like, let's use a mask of Alice and her rabbit. Come on, the real OGs know that Alice was chasing after a cat, right? And then the rabbit was just the rabbit who's always late. So anyway, let's look at what this looks like. And so here's our image. Here's our mask that we're going to be fitting our words into. And then let's do our word cloud, and we're going to fit our word cloud into that image. And oh my, I love it. Look at that. How cool is that? How cool is that? We have our little Alice in Wonderland and the little rabbit, but we have all the words that fit inside of her. That's so, I love it. I think it's so cool. I'm gonna see if I can save this. Save image. No, maybe I always had trouble kind of saving this actual image. Womp womp. Copy output to cleaved. Hmm. I'll see if I can ever figure out how to save this as an image. 'Cause I think it's so cool. Anyway, let's keep going. Obviously for our immigration data, we don't really have that many words, but what they're gonna do here is they're basically gonna like proportionally say the same country's name over and over again. And so this should hopefully say the same proportion. China and India kind of top out the top of our chart, so those words are bigger. Philippines, Haiti, Morocco. Pretty cool. Seaborn, we'll fly through these just because we did Seaborn last week. Definitely recommend spending more time on Seaborn here. Notice you can make the same graphs that you normally would in Matplotlib, but Seaborn adds some statistical flair. So for example, we have like our error bars on our bar charts. We can also do regression plots automatically without having to build out any model. We just have our scatter plots with our line of best fit as well as error bars around that. It's not magic, it's Seaborn. I love Seaborn. Again, please do that Kaggle learn if you have time. We can always customize everything, make the graph bigger, and we can end up with some pretty cool little regression plots here. So here we have our custom markers, our line of best fit, and all of our labels and colors. So yeah, and we did this in 5 lines of code, which is very cool. So isn't that awesome? And then yeah, we can change and fix the background as well. Again, with coding, you have full customization to style this however you want, right? To meet your enterprise's best practice. So same idea here. We're going to draw a regression plot for Denmark, Sweden, and Norway. And there it is. So we can see that our pattern has gone down. There's been less immigration since the 80s for the 3 Nordic countries. Cool. Uh, let's save this off and download it. All right, so we're only about 10 to 15 minutes left, so let's fly through the keynote and the quiz and wrap up this week. Alex, I don't have time to do the Folium exercise, but you can do it on your own time. And of course, as tradition, I already have it backed up in my GitHub in case you do want to see what it looks like. Yeah, let's say GitHub's been having some trouble rendering these. So you may have to download it, open it up yourself, or open it up in Colab. Or there we go. I guess it just worked. Oh, but the maps aren't loading. But anyway, if you run this in Colab, it should show everything. Remember how to do that. You either download the notebook, or if you go to Colab, you can just connect directly to GitHub and paste in my URL, and it should be off to the races. All right, so let's keep moving here. Let's go into Unit 3, which is going to be our final data viz of the lecture. We talk a lot about dashboards and data applications. Again, the big idea for dashboards is to provide that self-serve, easy way for stakeholders to interact with your data and your visualizations. And then this is where business intelligence comes into play. Your looker, click, quick site, plot, dashboard, Tableau, Power BI, those are all going to be drag and drop dashboard design for BI, right? But the problem with dashboards and BI tools is that you lose some of that flexibility and customization as if you were to code everything out yourself. So that leads us to data apps, which are going to be more robust than dashboards and allow us to actually host and run AI agents, machine learning models, as well as more data-driven interactive visualizations, such as Plotly, in one type of micro web application. Let me see if I can actually, we'll see what our friendly neighborhood AI has to say about this. BI dashboards versus data apps. Compare and contrast. Yeah, so like I said, BI dashboard is monitoring things that already happened, while data apps are more flexible, can allow you to interact with data directly and trigger additional downstream workloads, right? So a BI dashboard might show like, yeah, business intelligence, so showing like customer churn or look for executive reporting, KPI tracking, etc. But data applications might interact with machine learning models, right? A forecasting app or AI agents, right? Or other types of interactive visualizations, right? So on dashboard says here's what the data shows, showing that analytical storytelling, while a data app says, hey, let's automate decision making. Let's add more intelligence and more customization and more flexibility, right? And yeah, the line can blur. I've seen some like Tableau, really awesome Tableau folks who have built dashboards in Tableau that feel like data apps. And then I've also seen like some data scientists build data apps that are basically just a BI dashboard. Like there's no reason why that couldn't have been done in Tableau, besides the fact that they wanted that extra customization, right? Cool. So let's see. If you do some more Googling, you'll come up with like dashboard design concepts or dashboard design principles, like effective principles and best practices for building a dashboard design or for building dashboards. And then it's very similar to building like to static visualizations. How do we make sure that everything is clear, compelling, and can be communicated effectively to our downstream stakeholders, especially if it's not too technically challenging, right? So you're going to be seeing that they have a lot of text, a lot of textual context added to their dashboards and data applications that allows non-technical users to quickly like see quick hits and digest your metrics and give clear actions on what to do to either interact with the dashboard or to interact or do something outside of that, right? So yeah, you'll see that we usually read top to bottom, left to right. So we go 1, 2, 3, 4 is a good way to do it in terms of laying out your dashboard. And I think this is good too. Usually, typically want to have your filters here at the top and then your visuals down in the bottom. And then, yeah, maybe add in the most important things like your key performance indicators, your KPIs, your metrics in the top left, and then move into the rest of your visualizations. So I think it's a pretty good article. I'll share this out as well for like dashboard design concepts. Obviously, I don't have the time to go in this in depth, but definitely do some research, watch the videos. This is a bad dashboard. This is a cluttered, overwhelming dashboard, right? I didn't even read it. I just looked at it. I'm like, oh God. So again, like what is good, what is bad? Don't overload users with too many things. Again, apply the same concept of data to ink ratio, which we talked about in static visualizations as well here. Like, is there too much stuff going on? Is there too much irrelevant things? A lot of things that could be fairly redundant, right? Again, optimize your visualizations, add in your context, and just to make sure that your end users can use your dashboards correctly. So again, definitely watch the videos, do some of your own additional research to learn about best practices in data viz, etc. I don't think I have enough time to do the Plotly activity. Let me double check. I don't think I do. What did I do over here? I did do the Plotly. All right, we'll see if we have I don't know if we have that much time here. Hopefully, we'll see if this is fairly quick. We'll just kind of run the notebook and fly through it. Oh, I want to get into Dash apps and kind of be done in the next like 10 minutes. All right, so let's kind of look at this here. I know I started the recording a little bit late, so maybe this is also on me. Same idea. Let's just clear all the outputs, and then I'm going to run all cells just so it's running here. So again, what we're showing, we're introducing Plotly. Plotly is an interactive visualization library. This means that what it creates is interactive and has to live on a browser somewhere. If we download it, it's going to be downloaded as a static image, which kind of removes all the point of having a interactive. So see here on like on this empty on the scatter plot, I'm able to start like hovering over, interacting with the graph, interacting with the points. I see the annotations. I can zoom in on specific areas of the graph, and I can kind of zoom back out as needed, right? So pretty cool. And then we can download the image as a static image, like I mentioned as well. Like when we download it, we lose all interactivity. Interactivity means having some kind of web-based interface, right? All right. Let's see. So here's another one. It's a line chart, pretty good. And again, we can interact with it, which is nice. Bar charts that are interactive, histogram, which is interactive. So again, what we're showing is that we can move from the same static visualizations that we made with Matplotlib, Seaborn, and Pandas into an interactive one that can live in a browser that reacts whenever we hover over it. Pie chart, my favorite, sunburst. I love a good sunburst chart. Sunburst charts, when you like click on them, they like react and change, which is very cool. I love it. Oh my God, I love a good sunburst chart. And then here is a real, I guess I didn't do all of it. I'll leave some of these as exercise for the reader. But we're looking at flight data, flight delays, and yeah, I don't think I had time to do any of these live. But I did them live in my GitHub. If you go off and let me see if I can save this file. Oh my God, IBM is freaking out. Did that save? Hopefully. Oh my God, we crashed the notebook. If you go check my GitHub for this and our thing, this should be in 8.11, no, 8.12, 8.13. You'll see you have the introduction to Plotly here with the practice assignment part one. Oh no, I showed the wrong notebook. Oh well. Anyway, this is part one. It's going to show off. I guess we'll have to show it now. I guess we'll download the Plotly basics. Oh no, we showed the wrong notebook. It's fine. I don't know how many people actually watch this anyway. All right, let's keep going. Let's get into our practice project for 8.13 here. Dash is going to allow us to build data apps, which we'll review with our last activity of the lecture. All right, so we're going to start with, I'm going to skip over the Dash activity too. And I reviewed some Dash stuff in the preview for the week as well. Yeah, we're running very low on time. All right, so let's take a quick look at part one here. Part one is when we're going to be visualizing our wildfires in Australia. So again, same thing, clear outputs and run everything because we don't have time. And then hopefully this loads and starts running stuff. Cool. So in our data here, again, we're pulling in, we'll just scroll through it. We're pulling in our real data from Australia fires. We kind of have a breakdown of the data set, what it looks like, etc. Again, looking at the total area of burnt wildfire. From there, we're going to just build some data viz using Matplotlib. So here's a line chart of burnt fire, wildfires over time. See a big spike in 2011 and 2012. We can break this down by kind of month or quarter. And again, we do see those same spikes in consecutive summers in 2011 and 2012. And then we can even break this down further. I think we tried to break it down by like every single year and month, and you'll see that we kind of really messed up our labels. So we'll just go back to looking at it by year. Anyway, we noticed this peak in 2010 through 2013. So let's see if we can investigate it a little bit further. By using Seaborn, we can add those error bars, and we can see that since those error bars are pretty small, we have high confidence in these average fire brightness by all my regions, and we see that WA is just about the highest. We can visualize these as violin plots as well, which again show the distributions. Again, this is still fire brightness. And we can see that even though SA kind of had like a maximum that got a little bit high, the average of the distribution, I'm looking at the middle of my box plots, the middle of my humps, WA is still higher than all the other Australian regions. We can put this into a pie chart. Again, without the annotations, this would be hard to read. Again, which is bigger, orange versus pink? You don't really know. So again, I would not put the percentages in labels like this. Histogram, it looks like we're fairly normalized. It looks obviously better with Seaborn though. Seaborn is better for these statistical types of charts. And I think then we made, yeah, the stacked histogram chart, which it looks cool, but doesn't really tell you anything. It's pretty hard to read. So again, that is what it is. Scatter plots. Here's my little Folium map. Oh, cool. It actually loaded. We can see all the different wildfires across the different areas in Australia, which is pretty cool. And I think that's it. One last quick thing, if you're still watching on scatter plots, you can also lie with scatter plots. This can be known as like spurious correlations. This is where we kind of show and plot similar trends that actually have nothing in common here. So let's see what we got. The distance between Saturn and Earth has correlates well with the stock price of FMX. Let's see here. And let's see some other ones. UFO sightings in South Carolina correlate well with the total number of successful Mount Everest climbs. So again, we obviously know that there's no actual signal or relationship here between these two features, even if there is a correlation between them. So I'll probably paste this link too. I think it's pretty fun. Anyway, let's wrap up. Let's get into our data app and interactive dashboard. So we'll download this and jump over to the dashboard. Note for the dashboard activity, it uses a different user interface. We're going to be using our Visual Studio Code fork. So let's see how that goes. Again, if you checked my forum posts on this, which I don't know why you wouldn't be, you'll notice that when I talked about in the preview for the Dash apps that they use the wrong Python version. So just make sure to do Python 3, but we'll do that live here now as well. I also have a breakdown of like the syntax for Dash apps because it's like a whole crazy different syntax. Again, don't think and memorize the syntax for this. Understand the larger big idea of interactive dashboard design, data applications, BI tools, and when to use both and what they're all good and useful for. Long story short, though, for Dash apps, it's a reactive system. What that means is that instead of a Python notebook, which just runs like top to bottom, front to back, a application, we listen for events and then we handle those events, right? We react to a user click or to a scroll or to a filter or to a change, and then we update and change things dynamically as we go. So it's a little bit of a different system than a uh, just a Jupyter notebook. I was like, yeah, great job, YouTube, showing all the violin plots. This is for the recap video. So again, hopefully you're watching this stuff. We generate a lot of content for you in these boot camps or in these certifications. So hopefully they are of value to you. All right, so here's our IDE. Let's go ahead and build out our Dash application. First thing to do is get the tool ready. This is what I talked about earlier. Instead of using 3.8, we're just going to do pip3 and Python 3. And again, it's funny because if you scroll down, they actually do this correctly in the screenshot, but the code snippet's incorrect. So anyway, let's copy these over into our terminal and we'll just run this and hopefully it goes pretty fast. Install our tools. So again, notice I'm getting rid of the 0.8. I'll actually show you why here real quick. If I call Python dash dash version, or Python 3 dash dash version, our version of Python is Python 3.10, right? So using Python 3.8 is not going to work when we're running Python 3.10 in the environment. So just something to be aware of. Let's keep going here. Let's keep installing the rest of these. Notice now that we're installing Dash, and then we'll install it a different way just to make sure that it's completely installed. And last one, notice this last one is fine because it just uses pip3, not 3.8. All right, so now let's create our application. We're going to click on the two files up here. We're going to create a new file called dash wildfire.py. And then obviously you could follow the instructions on how to actually build this out, but I'm gonna run all the way to the end here because again, we don't want to, I don't really care about memorizing syntax. And I think it should give me the full application. So here we go. I'm gonna copy this and shove it here, excuse me. And the only thing I'm gonna change is at the bottom, this app.run, I'm gonna add in debug equals true, which allows me to make a change and have the application automatically refresh besides that. Just to run through what the code does, same thing as like everything else. It's pretty straightforward. We're going to read in our data sets. We're going to clean it up, do some feature engineering. And in the real world, obviously you'd want this to already be clean and you're going to be pulling from a database, not from a CSV. But we're going to clean it up. We're going to add in a header. Our header says Australia Wildfire Dashboard. We're going to add in our filters at the top, which again is best practice for dashboard design. We're going to have a drop down to select our region. Here's all of our region: Western Australia, Tasmania, Northern Territory, etc. We have a second filter where we can select the year. We're going to default to 2005. And then we're going to have two empty sections for where our plots will go. Then we have our callbacks. This is our event listeners. When somebody clicks or does something on our dashboard, we're going to take those filters as inputs. We're going to do work as in this function, and then we're going to return as an output our two plots. So essentially what we do here is when we hear a change as an event, we're going to take in those two filters. We're going to filter our data frame accordingly. We're going to make our plots. So we're going to make a pie chart and we're going to make a bar chart. We're going to return both of those graphs and then we should be good to go. All right, so let's go ahead and run the application. To run the application, all we have to do is run the file. Again, get rid of the 3.8. So it'll only be Python 3 dash wildfire.py, which is the name of the file. To open this, we're going to click on this icon down here to launch application, and we're running on 8050. So 8050, open this in a new tab, and magic. We have our filters, our radio buttons, and our drop down. We have our pie chart and we have our bar charts. And if I interact with it, this is where our event listener occurs. We trigger an event, we hear it, we react and update all the visualizations. Same thing for like a year, 2018 in Tasmania. Here's what our graphs look like. And then just to show how you why the debug equals true matters, if I go back up here and update a title like Profs Australia Wildfire Dashboard and save it, it automatically should update. Again, I crashed it because of a syntax issue, but it would work. And you can see that it's automatically updated. And I could say like maybe my last name or something. Save it and it automatically refreshes, hopefully. Save. And boom, there it goes. It automatically updated our title. So pretty cool. That allows us to iterate on this pretty quickly and update our graphs and things accordingly as we go. All right, so again, this is an example of a data app slash a dashboard all at once. Dash can be used for both, which is pretty cool. But again, big idea. Think about your BI tools, your Tableau, Power BIs. Translate what we've talked about event-driven behavior, best practices for data layouts, removing that clutter, Tufte's best practice principles, dashboard design best principles, right? That's really when to use what type of graph to tell what kind of story. That's really the meat of this week, not necessarily any of the specific syntax of Matplotlib, Seaborn, or Plotly Dash. All right, I think that's all I have here. I'm going to go ahead and run through the quiz, and then we'll wrap. We'll go through our big ideas and wrap. All right, so let's get to the quiz here. Remember, the only thing graded each week is the quiz until we get to the capstone. I guess I'll do a quick preview of the capstone. For the capstone, you will need to keep track of all the notebooks that you run. I do want you to submit all the notebooks in a GitHub. You do also have a quiz in week 9, but in week 10, we'll be submitting everything, right? All the notebooks, everything you've done, as well as your write-ups and slide decks and everything as well. So look out for our capstone launch, which will officially come in our preview video for, well, I'll do our week 9 launch tomorrow or Thursday, and then our week 9 preview video with our week 8 recap on Friday or Saturday. So look out for that coming up. We got our week 9 lecture Tuesday next week, and then we are just about done. One more week after that. All right, let's get after the quiz so we can wrap up this call. All right. Who created Matplotlib? That's going to be John Hunter. We said that at the beginning of class. At what point can you not modify a figure after it is rendered? Oh, we got 19 questions. Oh, God. Which code starts the command? Percentile matplotlib is the start of a command. All these other ones are magic functions. Line plot displays a series of data points connected by lines, I guess. Not a pie chart, not a bar chart, and it doesn't just show fragments. Which of the following is not a main layer of Matplotlib? Histogram is not a layer. Histogram is a visualization type. What's the best description of a Jupyter notebook? An open source web application that allows you to write code. Why not? The rest of these aren't. It's not just data viz, and it's not just a Python library. Matplotlib was initially designed to serve visualization. Again, best answer here, chart, graphing, weird answers. I think visualization is the best one. That's what we're doing this week, right? Data viz. What are the three built-in classes of the backend? Oh God, I think I can't remember what the answer is to this one. Figure, renderer, and canvas. Maybe we can ask AI. Oh, D. Figure, canvas, or renderer, and event. I always get that mixed up because I think figure and canvas are two separate things, but I think they are the same thing. So it's the second one, figure, canvas, the renderer, and the event. What's the purpose of a line plot? Display data trends over time. Yeah, again, best answer here. These are some of the like other weird answers. What's not ideal for comparing groups? Uh, What is not ideal for comparing categories or groups? That's a weird one. I'm gonna go with scatter plots are not good for comparing categories. Pie charts, I guess, are fine. Bar charts are fine. Line plots are fine. So we'll just go with scatter plot, I guess. Which layer within the matplotlib generates graphics and plots? That'll be the figure canvas. Oh no, it's the scripting layer. Maybe. Let's ask our AI tools again. These are some weird questions. I think it's the scripting layer. Yay! Look at me knowing things. Designed to generate the graphics happens in the scripting layer. The graphics are generated on the figure canvas. Figure layer is not a thing, and the back end is like all of it. How would you look at data distribution through five main dimensions? A box plot, probably. I would do box plot there. Two Seaborn plots. You got a regression plot and you got a cat plot. Python callback, there's like our dash thing, called by dash whenever something changes. A map shows different shaded areas. That is true. What do we need to decorate? The callback function, the input and output. Plotly graph contains JSON, which has a dictionary structure. True. Waffle charts represent categorical data, and the default map type is OpenStreetMap. All right, let's see how we did. I already got 1:30, so we gotta be done. I'm already late to my next call. Submit all and finish. Let's see how we did. Oh, woof. We got an A though, so I'll take it. Which ones did we miss? Number nine. The purpose of a line plot. I think it's gonna be A then. Capture trends and changes over time to see patterns and fluctuations. These are all, I don't know. It's dumb. Let's see. We missed a couple other ones here. I guess line plots and pie chart probably. They only wanted bar plot. Bar plot is good for comparing categories and groups. I would challenge this though, because we literally created a line plot to show India and China, which are like separate groups. And we also had pie charts that show the different wedges, which are also different categories. So I would challenge this. I think it wanted B, A, and C. So bar charts is the only one that is good. What else did we miss? Oh, we got the rest of them right. So it's just this awkward question about the uh, categorical data, and then the other one about line charts, where it was the same answer four times in a row. Oh no, this one. What was it? Yeah, this one. Capture data over time. Display data over time. Capture trends and changes over time. So dumb. Anyway, hopefully this was a helpful lecture. If you have any issues with the quiz, just reach out on the forums. Let me know. You have multiple attempts, so if you miss one, you can always go back and redo the quiz till you get it right. And I can also change grades on my end. So just reach out if you need any help. I'll post this onto YouTube and Zoom tonight, and I will see you all in the forums. Look for our capstone launch later this week, as well as our last couple lectures next week and the week after. All right, thanks everybody. I'll see you all in the next live session, and have a great rest of your week. See you in our capstone launch. Stay safe, stay curious, and I'll talk to you all soon. Cue the outro music. Do. Just kidding. I don't edit these. All right, bye. Thanks everybody.